This is the 11.1 lesson. So our teaching point is that today I'm going to teach you what a scale factor is and how to use it to solve for an unknown measurement using a proportion, because you may need to find missing measurements without actually being able to measure. Okay, let's look at our boxes and bullets. So we're going to be using this for the next couple days. You will notice the way it's set up is these are all different ratios in this column. This ratio is going to be one where we have no units. Then we're going to do one today where there are different units. So first of all, I mentioned that I'm going to tell you what a scale factor is. So this is our keywords. I'm going to double underline it. The scale factor is 1 to 20. What you're going to see with scale factors, and we're actually going to see this down at the bottom, scale factors have no labels. So I don't see labels on the 1 or the 20. So I know my scale factor is 1 to 20. If a model is 35 inches tall, they want to know how tall is the actual. Okay, these are going to be the steps. It says to use appropriate labels to represent your answer and then round to the nearest hundredth. The other thing you're going to see down on the bottom is a ratio here. Ratios are always model to actual. We also could say it this way, model colon actual. So the first number corresponds to the model, the second corresponds to the actual. So I know in this 1 to 20, 1 is the model and 20 is my actual. Okay, so the first step, it tells me write the scale factor as a ratio. So 1 to 20. It says set up a proportion. Proportion means I have an equal sign and I have another ratio on the other side. And then it says to add the other number and the label. Well, when I look up here, the other number is 35, so I need to decide where it goes. It tells me the model is 35, and we said model goes on top, actual on the bottom. So if I only do this, I didn't follow the directions. It says add the other number and the label. It's 35 inches. Okay, next it says add the variable and the label. Again, these two pieces are huge, and most of you are going to be a little on the lazy side and not show it, and that's going to cause you to get your answers wrong. So here's my x. Because there's no label here, it tells me that what this means, 1 unit in the model is 20 units in the actual. So whatever unit this is, this has to be the same, so I get inches again. So now it tells me to solve. So we have to think back to chapter 2 in the beginning of the year. We learned 3 ways to solve. So we're either going to use scaling up, we're going to use scaling down, or we're going to use means and extremes. Well, I see that right here. I can multiply both of these numbers times 35. When I multiply both of them times 35, I end up getting an answer here of 700 inches. Okay, so far you would tend to think that's your answer, but let's look at the last step. It says check that the answer is represented with appropriate units. If not, change to appropriate units. There is no way that I would take out a ruler and measure 700 inches. So I'm going to make a little note here. I wouldn't measure 700 inches. So I'm going to change it to feet. I know that there's 12 inches in a foot. So if I take the 700, if I divide it by 12, I'm going to get a decimal, but I'm going to round to the nearest hundredth, and I'm going to get 58.33 feet. That makes more sense that I would measure in feet. Okay, so again, no units. That's called a scale factor. The rest are just called scales if you see a unit. So we can actually work with scales as well. So let's look at the second one. The scale on a map. Okay, so again, it's not a scale factor this time, it's a scale. It's 1 inch to 20 miles. If the actual distance is 540 miles, how far apart is it on the map? Okay, let's follow the steps again. Write the scale as a ratio with the labels. Okay, 1 inch, 20 miles. set up a proportion, and add the other number and the label. Don't forget the label. So when I look back here, the other number is 540 miles, tells me it's the actual. Model to actual. So 540 miles has to go on the bottom. Okay, you're going to see that when you're given a label, we need the labels to match up across them. So now it tells me to add the variable. Here's my x and the label. This is not miles. My labels have to match across. So this is going to now be inches. Okay, so remember, in the prior example, there were no labels, which tells me the two labels are the same. So because this was inches, this is inches. Here, if the labels are different, the labels come straight across. Okay, so again, I'm going to look to see if I can, follow my next step. I'm either scaling up, scaling down, or using means and extremes. I can actually scale this up. This is times 27. So I get x is 27 inches. Okay, now it says check that your answer is represented with the appropriate units. If not, change it. Okay, so 27 inches, that's not too tough for me to measure. So I would probably accept that, but I'd accept other answers too. I could change it. I could take 27 and divide it by 12 to change it to feet. That would give me 2.25. So I could accept 2.25 feet. Or I might accept too that I know that 2 feet would be 24 inches. That means there's still 3 additional inches left. So I would be actually okay in this case with any one of those solutions.